Susan Skemp, welcome to the broadcast. You are the Executive Director of the Southeastern Energy Renewable Center.
Southeast, yes, right. It's a mouthful.
It's quite long. And that is down in Florida?
That's in Florida. It's focused or centered.
Whereabouts?
In Boca Raton at Florida Atlantic University, but that cuts across about 120 miles.
And what is your portfolio?
The portfolio that we're working on is the ocean current and ocean thermal energy conversion.
Now, ocean current, what are you doing in that?
We're in the process of developing a prototype, if you will, but more so the infrastructure to test and validate models, simulations, and also the feasibility of generating energy from the Gulf Stream, but keeping in mind the environmental stewardship at the same time.
What sort of turbines? Would it be turbines that you would put into the Gulf Stream?
Well, ours in particular is a very simplified design. It's there mainly to prove out the feasibility and to do all the testing and protocols for the ocean current. Eventually, we'll test devices, prototypes, small-scale devices for companies.
You've been a mechanical engineer for many years.
I have been, yes.
In fact, we met a long time ago through the Association of Mechanical Engineering.
Correct.
And you were in rocket science. That's literally in rockets.
I was literally in rockets.
And now you're in the ocean.
Right.
What have you carried from rockets to what you do now?
Well, a lot of it is about how you manage programs, how you look at design criteria, so you can take and transition from many different sectors. For example, from aerospace, from onshore wind or wind power generation. A lot of these bring the same design concepts.
Whenever you're getting a flow to turn something.
Exactly.
Whether it's wind turning a turbine.
Whether it's wind or whether you're using propulsion to lift off a rocket.
And airfoils are important.
Airfoils
what do you call airfoils when you put them in the water?
Well, if it's a ship or a vessel, you know, it's a propeller. In this case, we're talking about rotors.
Where does America stand in the competition? At this conference, this extraordinary conference, with 20 countries, 90 people presenting something, enormous conference really. American technology doesn't seem to be to the fore. Are we lagging as a country in American technology in ocean electric generation?
Well, I would say it's not necessarily the American technology, because we do have American technology that's working its way to testing and evaluation. It's more the infrastructure for testing here within the U.S. in the environmental permitting regulatory framework that we will have to address in putting commercialization or going to commercialization here in the U.S. So we're behind, say, Europe in that respect as far as testing and evaluation. We have a different permitting process, regulatory framework, and that's still evolving too.
Are you excited about the prospects of electricity?
Yes.
And ocean thermal gradients, these have been around as a concept for a long time. I know work has been done on them in Hawaii for quite a long time.
Correct.
Is that viable? Are we going to see that as a technology that's deployed?
We will. I think the first pilot program is actually going to be in Hawaii, but we're doing work off of Florida because we're seeing the same relative delta temperature requirement to make it economically feasible.
I was wondering whether you have the depth of ocean off Florida.
We actually are finding the potential in much shallower climes.
Oh, so you really don't necessarily need that much depth. You simply need the delta.
You need the delta temperature, and by putting it in a shallower area, it's actually closer to shore. So we are seeing places where it's about 200, 250 meters, that same capability.
What are the temperatures that you require in the delta?
A minimum of about 20 degrees Celsius. That's to make it economically feasible.
And you believe it to be economically
Well, that's
feasible?
what we're already seeing, yes.
One of the things that when we started looking at alternative energies way back in the early 70s after the Arab oil embargo and some other national shocks on the energy scene, we didn't put the same effort into the ocean as we put into wind and solar. Was there a reason for that? You see the result now is that wind is commercially deployed, solar is right behind it, and we haven't seen any large-scale deployment of ocean technology.
True. And I think there needs, possibly at that time, and this is my perspective, you go for the low-hanging fruit. So if you can put emphasis for renewables or alternatives on an area on the coastline or on land, let's say, that's the low-hanging fruit. There's a lot more known about environmental concerns. The regulatory process is established. But I think the evolution of the oil and gas industry as an industry over the past 30 years has then helped to move and consider ocean energy, whatever the form, wave, tidal, as an alternative, viable alternative.
Is that because there's been so much offshore drilling? So much has been learned about pipes and corrosion?
Corrosion, and regulatory framework, what we need to consider, what is relevant or maybe over the top. So a lot of what we're doing now in looking at ocean energy, especially any deep water offshore wind, ocean current, which is in deeper water, that then translates from oil and gas, not for one, but we learn from that industry.
So that this is really the beginning of a very exciting period in ocean technology, whereas the others are maturing. Some of the creative juice has gone out of them, if you will.
Creative juice has gone out.
And there's lots of creative juice in this conference, clearly.
Well, I think it's not only the conference, but what I'm seeing. I was in industry for over 30 years, in the aerospace industry. And what I'm seeing with kids today, both in the K through 12 level, but students who are going into marine science, the engineering disciplines that support this industry, they're excited about it. And I think there's a resurgence, even more so today, about environmental stewardship, but recognizing that we've got to look for alternative ways to producing energy and creating that infrastructure. And I think the kids are we're seeing that with kids today.
How do we stop frightening kids off math and science? Is it because we overemphasize math and they say, oh,
well,
and they don't understand the true excitement of science and engineering? And
that is possibly, yes, one of the, it's a messaging, okay? But I think an approach that we're taking with the center that I run at Florida Atlantic is we've developed a curriculum to reach out to teachers in the K through 12 area to then help them understand about the excitement of how you apply the math skills and the engineering. And
I think
mentors.
that we don't always explain to them that it's building big, marvelous, exciting things.
You're right.
We say math and science, and that has visions of lines of figures, of calculating machines, computers, indoors, locked away with all those numbers, instead of being out there with all those fabulous projects.
Exactly. You're right.
That's
and
wonderful.
That's what I enjoy.
It's wonderful to talk to you.
Thank you
Good
very
luck
much.
with your center.
Appreciate it. Thank you.
Excellent. Thank you.